Hi, Steven here. Welcome to another video of the MATLAB Crash Course series. Today we're going to be talking about indexing vectors and matrices. So let's look at a little bit of the topics we have here. So for today we're going to be looking at basic indexing techniques. We're going to be looking at some advanced indexing techniques. And then we're finally going to look at modifying vectors as well as matrices. I'm going to explain what all these terms mean. Might not be familiar with it right now. One thing I expect that you understand before watching this video is how to create vectors and matrices in MATLAB. So if you do not know how to do that, I recommend checking out my last video where I talked about I gave an introduction to vectors and matrices in MATLAB. Highly recommend looking at that before proceeding to this video. So the first thing we're going to talk about here is some basic indexing techniques. So indexing a vector or matrix essentially means to individually select certain elements from that vector or matrix. So essentially, let's say I have this vector here. There's 5 elements in it, 5 numbers, but let's say I only want to retrieve one of those numbers in there. Remember, a vector is stored as one variable, so you get all 5 of those numbers in one variable. But let's say you only want one of those numbers or a few of those numbers, not the entire vector. How would we go about doing that? Well, MATLAB has a very convenient way of individuals allowing them to retrieve certain elements from a vector or a matrix. So first we're going to look at how to do so with a vector. So to index either a row or column vector, place the integer position value in parentheses after the variable name. So essentially what that means is whatever element you want to put in parentheses after the variable name of that vector, the position that that element is located. So the best way to look at this would be to look at an example. So let's say you want to retrieve this 45 here. The 45 is the second element of this row vector, excuse me. So what you'd want to do is, let's say for example this vector is named vec, V-E-C. If the vector is named vec, what you're going to want to do is say, since it's the second element, vec, and then in parentheses put a 2 after for the second element. That would give you a 45. So let's actually try this in MATLAB. So I have the vector vec already saved. If you don't know how to create this vector, once again, I'd recommend going back to my previous video, an introduction to vectors and matrices. So we have this vector here, and I want to retrieve the 45. What I would say is vec, and then in parentheses, I would put a 2. If I click enter, it's going to say that the answer is 45. That means that vec of 2 will return the second element. It will return a 45. I could save this as another variable if I want. I could say num equals vec of 2. So then num would be 45. I could just type out num then, and num would be 45. So that's how you would want to index. What's important to recognize with MATLAB is that all indexing starts at the integer 1. Meaning that if I wanted to retrieve the first element, I need to put vec of 1 in parentheses. This is a lot different than anyone that's familiar with other programming languages. If you're familiar with C or Java, indexing starts at 0. But MATLAB makes it very convenient. The first element, you put a 1 in there. That's very convenient. You don't have to do any subtraction or anything like that. If you want the first element, you just type vec of 1. So a few more examples. Vec of, and then in brackets, 1 and 4, will give the first and the fourth elements, which is the 21 and 81. So if I put vec of 1 and 4, you'll see I return the first element and the fourth element. Now see, the 1 and the 4 have to be in brackets. If it's not in brackets, there's going to actually be an error that retrieves. MATLAB's going to think you're doing something different. So let's try this example here. So if I say vec, and then in brackets, I put 1 space 4, and then close the parentheses, it returns the first and the fourth element. You'll see here the 21 and the 81. That's the first and the fourth element. I'm going to clear that there. Let's go back here. Another example here, vec, and then in the parentheses 3:5 will give a 57, 81, and 77. That's the third, fourth, and fifth elements. If you remember, colon notation is used to represent all the integers between a starting and ending value. The starting value is 3, the ending value is 5, so it will return all integers between 3 and 5. That means the 3, 4, and 5. That's a vector, in this case, 3, 4, 5. That means it will return the third, fourth, and fifth elements of this matrix, the 57, 81, and 77. Let's try this out real quick. So vec 3:5. It does exactly that. It returns the last 3 elements. One final note here, there's a keyword that can be used, and that word is end, and that will return the final element of a vector. This is really useful if you don't know the length of a vector, for example. If you don't know how long your vector is, you can just use the keyword end, and that will return the final element. So for example, I can say vec of end, and that will give me the last element. If you remember what vec looked like, vec looks like this here. The last element is 77. So if I type vec and then in parentheses end, it will return the ending element, the 77. I can even say something like vec of end minus 1. This will put me one element before the last element, which is 81. 81 is one element before the end, before 77. This can be pretty useful, once again, if you don't know the length. If you have multiple elements but you don't know how long your vector is. All right. Some more basic indexing techniques that can be used with matrices. So indexing a matrix using a single value gives the element at the location with the reference of going down the columns. So this might be a little confusing at first, but here's what I mean. We can do the same thing with vectors. We can just put a single element, a single integer in there. I can say mat of 4, for example, but you have to be careful when looking at numbering them. So many people think that in order to index, okay, this is the first element, this is 2, this is 3, this is 4, but that's not true. For matrices, if you just put a single number, that will take a reference of going down the columns, meaning that this is 1, this is position 2, this is position 3, this is position 4. So if you want to index them, you have to go down the columns and work your way around. So for example here, let's say mat of 8 would return a 0. So if you look at it, we have position 1, 2, 3, 4, 5, 6, 7, 8. When using a single number, you have to have a reference of going down the columns, not across the rows. Do not count 1, 2, 3, 4, 5, 6, 7, 8. It will not return a 6. Let's actually do that, for example. So I have mat already created on here. And if I say mat of 8, it will give me the 0. It takes a reference of going down the columns. This is really important if you want to use a single number. This isn't as common though, because it can get a little confusing and you have to like count and say, okay, like where do I want to go? What element number is this? So many people will actually use indexing with 2 values, which is a lot more much more common. Indexing with 2 values gives you a row value and a column value associated to the matrix. So for example, if I say mat 3, 4, that means, okay, MATLAB, give me the element that lies at the 3rd row and the 4th column. So in this case here, let's look at the 3rd row. So this is row 1, row 2. So row 3 is right here. And I want to go to the 4th column. So this is column 1, 2, 3. So this is the 4th column. 3rd row, 4th column. That will give me a 1. So mat 3, 4 gives you a 1 at the 3rd row and 4th column. So let's do that here. Mat 3, 4. Once again, that returns a 1, the 3rd row and 4th column. All right, now let's look at some advanced indexing techniques. So for matrices specifically, colon notation can be utilized. So for example, you can get a variety of values in this matrix by utilizing colons. So mat 1, 2, 3 would return all the values in the 1st through 2nd row and in the 3rd column. So the best way to visualize how the colon notation works and where we're exactly looking is to use to just kind of view it as looking at the intersection of rows and columns. So I'm going to highlight a bit of, I'm going to highlight some things just to show what exactly we're doing here. So mat 1, 2, that means that, okay, we're going to look at the 1st through 2nd columns. So that would mean, rows. So that means we're going to look at, okay, 1, 2. That means we're going to look at row 1, we don't want that. We don't want the blue marker, we want the highlighting. So we're going to look at the 1st row and the 2nd row because it says 1, 2, 1st through 2nd rows. Then we want to look at the 3rd column. So we're going to put another highlight in the 3rd column right here. What MATLAB is going to return is all the locations where there's an intersection between the row and column. So if you look here, all the intersections lie at 5 and 7. There's an intersection between a row and column at 5 and an intersection between a row and column at 7. So that is what MATLAB is going to return when you index like this. So it's going to return 5, 7, and notice when I actually do it here, so if I type mat 1, 2, 3, it returns the 5 and 7 as a column vector. That's because if you look here, we have this existing as a column vector currently. The 5 is on top of the 7. It's a column vector in this case. So that's what MATLAB is going to return. So let's do another example kind of like this. So this one's very similar. So mat 2:3, comma 3:4 is going to return the intersection that results from the second through third row and the third through fourth column. Once again, the best way to look at it is by looking at the intersections. So for rows, we have 2 through 3. So that means that we want to highlight the second row and the third row. For columns, we have 3:4. So we want to look at the third column and the fourth column. And then we want to look at all the areas of intersection. So for areas of intersection, we have this 7, this 6, this 4, and this 1. So MATLAB is going to return a matrix that consists of these values. And it'll look exactly like this small matrix here. If we assume, if we're just looking at, let's say we're looking at just this matrix right here. That's what MATLAB is going to return. It's going to return those 4 numbers as a matrix. So let's actually try that out. Let's clear some stuff out of our way. So we got mat 2:3, comma 3:4. And it's going to return that little matrix, like I said, 7, 6, 4, 1. If you go back here, 7, 6, 4, 1. It's going to return exactly that. All right, one more to look at. Mat 3 returns every element in the third column. When you put a colon in a position, either the row or column, it assumes every single row or every column, depending on whether you have it as the first or second element argument respectively. So in this case, we want to look at the third column as it says here. So this is the third column. But we want to look, since we have a colon here, we want to look at every single element in that third column. So it's going to return this entire third column. When you want to just get a row or just get a column, you want to use a colon. So for example, let's actually just do this on MATLAB. So mat 3, that gives me the entire third column, which is depicted right here. If I wanted the whole second row, for example, I would say mat 2, colon. Since I want the row, I put the colon in the second argument because that says, okay, we want to get every single element in the column. We want the entire second row. If I click enter, it gives me the second row of that matrix. Let's go back here. Let us erase what we have here. All right, I want to exit out of this. Changes, no. Time you exit out of this, it has to reload for some reason. All right, some more advanced indexing techniques for MATLAB. So for matrices. So here in this case, we have something a little familiar, but instead of colons, we're using brackets. So mat, and then in brackets 1 and 3, then comma 2 returns the intersection between the first and third row and the second column. Once again, the best way to look at this is in terms of intersections. So for rows, we have row 1 and row 3. So we're going to highlight row 1 and highlight row 3. For columns, we have the second column. So we're going to highlight the second column here. Where's our intersection? We have an intersection at the 13 and the 7, which means it's going to return to us a column vector of 13 and 7. So once again, let's try that. So mat, and then in brackets 1, 3, and then comma 2, we get the 13 and the 7. You have to look at the intersection. That's the easiest way to do. All right, so one more example. So mat, and then in brackets 1, 4, and then another set of brackets 2, 3. Once again, let's just look at the intersections. So we have the first row and the fourth row. That's our first argument. Then we have for columns, we have second column and third column. Where's our areas of intersection? 13, 5, 0, 7. So it's going to return a matrix, a 2x2 matrix with 13, 5, 0, 7. Let's do it. Mat, and then in brackets 1, 4, and then in another set of brackets 2, 3, 13, 5, 0, 7. That's exactly the areas we had highlighted over here. So once again, the easiest way to understand what numbers are going to be indexed is by highlighting and looking at the areas of intersection. What rows and columns, where's our areas of intersection? That's what elements are going to be returned in every case. And that's the easiest way to understand how to index and where we're looking for. Don't want to save any changes here. Wait for it to reload yet again. So now we're going to do, once this loads back up, we're going to do a few examples looking at just indexing in general. So an example here, create the matrix that's shown on the right. So here we have 4, 2, 13, 6, 3, 78. So we're going to create that matrix there. So let's call it mat1. We're going to say mat1 equals, it was 4, 2, then looking back over here, 13, 6, so 13, 6, and 378. So 378. So we have created this matrix right here. It's a 3 by 2 matrix, 3 rows, 2 columns. All right, show 2 ways to retrieve the element 6. So you can see that the 6 is right here, and we want to retrieve it in 2 separate ways. Like we said on previous slide, there are 2 separate ways to do it. You can either use a single number, which will count the position based on the columns, or you can use 2 numbers, which will give you the row and column. Let's do the first way first. So what single integer would we have to enter in our variable to retrieve the 6? So if we count going down the columns, we see this is position 1, position 2, 3, 4. So the 6 lies at position 5. So that means if we were to type out mat1 and then in parentheses 5, that's going to give us the 6. All right, so that's one way to do it. The second way to do it is by using 2 numbers, looking at a row and column value. So the 6 lies in the second row and lies in the second column. That means that we can type mat1 2, 2 for second row, second column, and that's going to give us the 6. So those are the 2 separate ways you can get the element 6, either the 5th position going down the columns or row 2, column 2, that intersection. That's going to give us the value 6. Retrieve the elements 4 and 13 as a column vector. All right, so let's see, how exactly would we do that? Well, so let's see what we have here. So the 4, I'm going to highlight again just to show, the 4 is located in the first row here. And the 13 is located in the second row here. As well, both of them are located in the first column. So we created some lines here to show our intersection. Now we kind of have to do the reverse of what we were doing in the past. Instead of saying what would this return, we have to say how do we get there? So we can see here we have the first and second row and we have the first column. So going back to what we did earlier, we could say mat, and then inside our parentheses here, the first thing we want to say is the first and second row. There are 2 ways we can do this. We can either say in brackets 1, 2 in brackets, or, and I think this is a better way of doing it, 1, 2. This will give us the first and second row. Then we want to say the first column. We put a 1 there to represent the first column. If we click enter, it will automatically give, wait a minute. Oh, my apologies. I used mat instead of mat1. Mat was the 4 by 4 matrix we were working with earlier. If I use mat1 and do that same thing, so let's go back up. And if I say mat1, it's going to give us the 4 and 13 as we were saying, the 4, 13, and it's already as a column vector because that's how they're arranged in the matrix as a column vector. All right, let's erase these. All right, retrieve the second column of this matrix as a row vector. All right, so the second column of this matrix, that would be this whole thing there. We want to retrieve this whole thing, but we want to retrieve it as a row vector, not a column vector. So let's see exactly what we'd have to do here. First, let's try retrieving it as just a column vector. We want the entire second row. So we would say, second column, my apologies. So we're going to say mat1, and then since we want the entire second column, we're going to use the colon notation. So we're going to say colon, comma 2. This is going to return the entire second column because we have the colon meaning everything in the rows. We're not going to worry about the rows. We just want the second column. That's the notation we use for this. If I click enter, it gives us the second column, but it gives us a column vector. We wanted to retrieve it as a row vector. Once again, in the previous video, I discussed the way you can do this is by transposing this vector. Take the transpose of it. And the way you do that in MATLAB is by adding an apostrophe at the end. So I can take what I had earlier typed, mat1, colon, comma 2, and if I put an apostrophe after it, it's going to give me a row vector of the second column. The apostrophe took the transpose of it, so that gives us exactly what we want. All right, the final thing to do here, retrieve the matrix that consists of the 4 corner elements. So the 4 corner elements are going to be the 4, 2, 3, 7. Once again, let's kind of highlight it out and see what our areas of intersection are. So we have the first row here. We have nothing in the second row. And then for the third row, we have elements there. All right, and then the 4, 2, 3, and 7, well, the 4 and 3 are in the first column, and the 2 and 78 are in the second column here. So this is what it kind of looks like. So how would we use MATLAB to get this? Well, we want to retrieve the intersection from rows 1 and 3, as well as the columns 1 and 2. So we want the first and third row. Let's do that first. So we're going to say mat1, and we want, let's clear this down here. So mat1. So then let's see, we want the first and third row. So we're going to use our brackets here because we only want 1 and 3. We don't want the 2 in between. So we have to use the brackets, 1 space 3, close, and then we want the first and second column. We want both the columns. So in that case, we can say 1 colon 2 for first through second columns. If we do this, we get 4, 2, 3, and 78. 4, 2, 3, 78. So just to recap, the 1 and 3 represented the first and third row. The 1 colon 2 represented the first and second column. 1 row, the 3 row, the first column, the second column. You have to look at the areas of intersection. That's really the only way you can see how to index these exactly the way we want to. Let's erase all these. Let's exit out here once again so we can move on. Another example we have here. Create a 3 by 3 matrix of random integer values from 2 to 60. Alright, if you remember from the last video, the way we create a matrix of random integers is by using the randi function, R-A-N-D-I. So let's see, so we want integer values from 20 to 60. We want to be a 3 by 3 matrix. So if we go on MATLAB here, let's see, what should we call our matrix here? Let's call it RMAT for random matrix. We're going to say RMAT equals, and then we're going to use the randi function. Our integers we want are from 20 to 60, so we put 20 and 60 in brackets. We want it to be a 3 by 3 matrix, so we can just put a 3 after, and that'll give us a 3 by 3 matrix, because it's a square matrix. If I click enter, alright, looks like we have exactly what we wanted. We have random integers going from 20 to 60. If you try this on MATLAB yourself, you're going to probably have completely different set of random integers, and that's okay. I'm going to use this matrix I have right here for demonstration though. Retrieve the middle element using 2 different methods. Alright, so the middle element in this case is the 45 here. We can retrieve that in 2 different methods like we did in the first example. So the first way we can do that is by counting the positions based on columns. So 1, 2, 3, 4, 5, it's the 5th element. So I can say RMAT and then 5 in parentheses. That gives me the middle element. I can also use the row and column notation again. So I can say, all right, it's in the second row and second column. So I can say RMAT 2, 2, and that gives me the middle element. Retrieve the bottom row of the matrix. So we want the entire bottom row. So let's clear, let's look at our matrix. So the bottom row is going to be right here. So we want to retrieve that whole row. Once again, we can use the colon notation here. I can say RMAT. So we want the third row, and we want the whole third row. We don't care about what columns we get. So we use the colon for our column value. I click enter, we get the entire third row. Finally, retrieve the top left 2 by 2 matrix. So once again, we have to look at our intersection here. We want the top left 2 by 2 matrix. That's going to be the 53, 57, 57, 45. Those 4 values. So let's see, these values lie in the first row and the second row, as well as the first column and the second column. That's where those lie. So I have to say RMAT, we want the first through second rows, and we want the first through second columns. This is going to give us that little 2 by 2 matrix, which is exactly what we get right here. The first through second rows and the first through second columns gives us that matrix. So that's all we got there. Now we're going to take a look at modifying our matrices and modifying our vectors. So modifying means to do one of the following. It means we can add, remove, or change certain elements in a vector or matrix. So MATLAB allows for indexing techniques to be used to allow for modification. And it's very similar to like what we were just doing. We can use those indexing techniques from earlier to change certain parts of our matrix or vector. The general format is you have your variable name, and then in parentheses you put your index notation, and you assign that as some new element, essentially. And the best way to look at that again is by looking at some examples. So first we're going to talk about removing an element. So to remove an element from a vector, assign the element as a set of brackets. So let's say we had this vector again. So vec, this is our vector. I'm going to make a copy of that vector, cvec. I'm going to make a copy of that vector just for now so I don't have to change up my original vector. So cvec is going to be the exact same thing for now, but I'm going to modify cvec. So let's go back. So for example, to remove the fourth element, this could be called mat, for example, so, or whatever. You take the name of your vector and you assign it as a set of brackets. So this is my vector here. So if I want to change it, meaning I want to remove the fourth element, what I would do is I would say cvec, because that's what I have here. So cvec of 4 equals a set of brackets. So if we look here, the fourth element is the 81. And if I make this assignment here, cvec 4 equals the brackets, I get a new vector where the fourth element is now gone. It now only has 4 elements, but the 77 moved from the fifth element to the fourth element, and the 81's gone. Not only can we just remove a single element, we can remove multiple elements using that same indexing notation. To remove the second through fourth elements, use mat, or whatever your variable name is, 2:4, and assign it as the brackets. So let's change cvec again. Let's say cvec equals vec. So cvec is back to normal. So we can say cvec 2:4 is going to equal the set of brackets. Now we only have 2 elements of our matrix, because if you look back to what we had originally, we had all 5, but we removed these elements, 2 through 4, 2:4. That deletes all of them, and we're left with only a vector of 2 elements. To remove the first and third element, you can do the same thing. You have to use the bracket notation that we did for indexing. So if we go back here, let's make cvec back to normal again. So we have cvec, and then if we want to remove the first and third elements, we'd say cvec, and then we'd say 1-3, and we're going to assign that equal to the empty brackets. And that's what we get here. We remove the first element as well as the third element. So now all we have left are the second, fourth, and fifth elements. All right, adding an element. So elements can be directly added at the end of vectors very easily, but there's not a direct way to add any element or new element at the beginning or middle without just creating a new vector in entirety. But we can add a new element at the end of a vector very easily. So let's see, to add, that is not how you spell 2, unfortunately. That's yikes. So to add a 33 as a 6th element, use mat, or whatever your vector name is, of 6 equal 33, for example. And let's just once again do an example of this. Let's bring cvec back to life, or whatever you want to say. So cvec. So if we want to add a 6th element, the number 33, I can say cvec of 6 equals 33. That's going to add on a new element at the end here. Something that's really cool even is we can add an element beyond the end. We can add one as, say, let's add a 10th element. Even though we don't have a 7th, 8th, or 9th, we can still do that. But watch what happens. If I say cvec of 10 equals, let's say 12, for example, watch what happens. So it added the 12 as the 10th element, but everything in between that we didn't have got filled in as a 0. So that means that here we stopped at our 6th element. The 7th, 8th, and 9th elements are now 0s, just because I skipped straight to 10. That's something that can be of use. Once again, it has to be at the end. You can't put the 12, say, in here without just replacing it, for example. That's just going to completely replace it, which is what we're going to talk about next. So changing elements here. So what we can do is, if we don't like the value of a certain element in our vector or matrix, we can replace it. So I can say mat of 3 equals 23, and that would replace the 57 with the 23 here. So once again, let's change our cvec back to normal. So we can say cvec of 3 equals 23. So what this is going to do is it's going to replace the third element with a 23. So I could type this here. So now I have a 23 as the third element. I no longer have a 57. It's a very simple way you use your indexing techniques to change certain elements. Likewise, we can say mat 3:4 equals 923. That would change the third and fourth elements here, so the third and fourth one, to 9 and 23 respectively. So again, let's just do that example. So cvec equals vec. We're back to normal. I'll say cvec 3, 4 And then what numbers do we have here? 9 and 23. Okay, so, and I have to use brackets here or else MATLAB is going to think something is messed up. So I'm going to say 9 space 23, close my brackets. It replaced the third and fourth element with a 9 and 23 respectively. That's how we can modify those here. The same indexing techniques can be used to replace elements in the vector with other values. All those indexing techniques I talked about earlier, we can use those in a way. If you want to replace an entire left corner matrix, you can do that. You would just have to enter a new matrix that you want to enter in there. All right, so now we're going to look at modifying matrices. So the same indexing techniques as we previously discussed can be used to modify the matrices, but there are a few differences with modifying. So to remove elements of a matrix, you cannot remove any part of a matrix that isn't either an entire row or an entire column. It just will not work in most cases. There might be a few cases where you'll remove it, but you won't be left with a matrix. You'd be left with just a vector. Just assume in most cases that you just cannot remove a single element or a couple elements. You either have to remove an entire row or entire column. That's all you can remove to return a new matrix. Matrices have very strict formatting, and they have to have a complete row and a complete column. You can't just take out a certain element. Any portion of a matrix that is an entire row or column cannot be removed. Only entire rows or columns can be added to the matrix. Once again, you can't just add elements at the end randomly. You have to either add an entire new row or an entire new column to your matrix. But any portion of the matrix can be changed, can be modified. You can change values in a matrix. You can change any values you want in the matrix. It's just that removing and adding have certain limitations where only you can be dealing with entire rows or entire columns. All right, let's do a couple examples just to finish off this video. So first example here, create the matrix to the right. All right, let's do that. Shouldn't be too bad. Let's get that out of the way. So let's see, 7, 24, 6. So I'm gonna call this mat2. So mat2 equals, and we're gonna call, let's see, what all do we have here? So it was 7, 24, 6. So 7, 24, 6. We have 10, 1, 23. So 10, 1, 23. 55, 32, 9. So 55, 32, 9. If we look at it, that's our matrix here. I believe it looks the same. Right, let's do the example. So replace the 24 with a 26. So let's see. So here's the 24 here. And so we want to replace it with a 26. So let's take a look. So let's use our indexing technique first. Where's the 24? The 24 is in the first row and second column. So we can say mat2, first row, second column, and we want to change it to a 26. So we're going to say it equals 26. When we do that, it does exactly what we want. The 24 is now a 26. All right, replace the 32 and 9 with a 30 and 11. So let's see, where's the 32 and 9? So that's going to be right here. We have a 32 and a 9, but we want to replace it with a 30 and 11. All right, so how exactly would we do that here? So looking at this here, the 32 and 9. So both of them lie in the third row. So we know our row is going to be the third row. The columns we want are the second column and third column. The 32 is in the second column, the 9's in the third column. So those are going to be where intersections are. So mat2, we just want the third row. And then for columns, we want second column through the third column, 2 and 3. So that's going to give us the 32 and 9. And we want to replace them with a 30 and 11. So we're going to say it equals 30, 11. If we do that, you'll see the 32 and 9 are now replaced with a 30 and the 11. All right, remove the final column from the matrix. So once again, this is removing with a matrix, but since it's not just one element or a couple elements, it's an entire column. We want to remove this whole column from the matrix. We can do that. So let's clear some stuff. Let's see what mat2 equals right now. We want to remove the whole column, the whole last column. The last column is the 6, 23, and 11. So that means we're going to say mat2, we want the entire third column. So that means we're going to put a colon in our rows because we don't care about the rows. We just want the third column. So this is going to give us just the third column. And we're going to say it equals, in this case, it's going to equal an empty brackets, meaning that it's just going to be removed. It's going to be empty. If we do that, we get that column completely removed. This is what we're left with, just the first two columns. Add a new column to the matrix with the numbers 1, 2, and 3. So now we're just going to go back and add, we're going to add a new column just where we removed it. So we're going to do the same thing here. We can say mat2, we're going to say we're going to add something, and we're going to make it the third column. That means we're going to use the same notation. We're going to say colon, comma, 3. That means currently there is no third column, but if there were a third column, we're going to say it's going to equal the elements 1, 2, and 3. And remember, this has to be a column vector because we're adding them as a column. So we have to put the apostrophe at the end, because right now it's a row vector, we make it a column vector with the apostrophe. So this says, all right, we have the third column, and we're going to add a third column being this column vector here. If we click enter, it does exactly that. Puts the 1, 2, and 3 as the third column, which is what it's exactly what we wanted. All right, another example here. Create a vector of integers starting at 2 and ending at 71 with a step size of 3 between each element. This goes back to creating vectors again in my last video. So if we look here, let's clear what we have here. So we want to create a vector of integers starting at 2, ending at 71, and there's a step size of 3 between each element. So let's call this vector evec. It's an example vector. So let's see, it started at 2 and ends at 71. So it started at 2. There was a step size of 3. So we're going to use the colon notation again. So 2 colon 3 colon 71. If you don't remember what this means, once again, I recommend going back to my last video. So this creates a big, long row vector that we have here. 2 through 71 with a step size of 3, meaning 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, all the way until we get to 71. That's exactly what we want here. So now, what would be the 15th element in this vector? So I'm going to actually, I'm going to remove what we have here right now just for sake. So what would the 15th element be? So without going back and seeing, like counting it all out, we can do a simple indexing technique to see what the 15th element would be. We can say evec, and then we can put a 15 in the parentheses. This will give us the 15th element. And if I click enter, it tells us that the 15th element is 44. So we were able to find the 15th element without going back and counting every single element here. Remove the final 3 elements from the vector. All right, let's see if there's a way we can do this. So remember, we can use the brackets, the empty set of brackets, to remove elements, but we don't know what numbers to put in here. We don't know what to put. We don't know if it's like evec, how many elements did we have? We don't know if it's, how many were there? Were there like 20? Is it 20 through 22? Does that get rid of the last 3? I'm not too sure. But there is an easier way we can do it without knowing how many elements were in this vector. We could try doing some math and figuring out how many elements there were, but the easiest thing to do is to use that keyword end like we did earlier. So if we say evec, and we want the last 3 elements, that would be the ending element, ending -1, and ending -2. Those are going to give us the last 3 elements. So if I say, okay, remove everything from end -2 through end, that's going to actually remove the last 3 elements, because end was the last element, end -2 is the second to last, end -3 is the third to last. So that means we're removing the last 3 elements by doing this. And if I click enter, oh, my apologies, that right there just indexed them. If I want to actually remove them, I go back to what I had earlier and say it equals a set of brackets. That's how you remove elements. So if I do that, those are the last 3 elements. If I assign them as a set of brackets, it's going to remove them. So now we just have from 2 to 62. Those are the last, those are all the elements. We removed the last 3. All right, change the 5th element to 12,345. So we're going to go back here, the 5th element, 1, 2, 3, 4, 5. So we're going to change that element to 12,345. Once again, the way we can do that is just by saying evec, it's the 5th element, so we're going to put the 5 in parentheses, equals 1, 2, 3, 4, 5. If we do that, you'll see the 5th element right there is right here. It's the 12,345. Remove what we have here. Let's see what we have here. The final thing to do is add a new element at the end of the vector. So we want to add a new one at the end of the vector. So let's see. Once again, we don't know exactly how many elements we have here. But once again, we can use that end keyword. So if I say evec of end +1, I can assign it as some new value or new whatever integer I want. So let's just make up, I don't know, let's say 77, for example. So I'm going to say the ending element is whatever's currently at the end. To add one right after that, I'm going to say end +1. And if I do that, the last element was 62, but since we added one beyond that, the last element is now 77. All right, and that's all I have for this video. Thank you for watching, and good luck on your MATLAB endeavors.